Hello guys, welcome back into the mathematical lesson where we are still continuing with the riders. But this is the last lesson of these riders, right? Okay, now we are going to do this question because we did this one in the previous lesson. Now we are going to do this question 11 here. Okay, now we are given that O is the center of the larger circle, which is this one, right? Yes, RTAP, RTAP. OP is the diameter of the smaller circle, PSO, PSO. NP is the tangent to the bigger circle and the smaller circle at P. RN is perpendicular to NP. We have 90 degrees here. Now, let P1 to be X. Okay, now doing our analysis, the Dr. Cape Town technique, DRCPT, right? D is the diameter of the circle. This is the diameter of the larger circle. Therefore, this angle here is 90 degrees, right? And the diameter of the smaller circle is this one. Therefore, this is 90 degrees. That is the diameter. Let us go for the radius. This is the radius of the larger circle. This is the radius of the larger circle. Therefore, this angle is equals to this angle. Angles opposite equal sides. And this angle here is equals to that angle because of this radius here. Angles opposite equal sides. Now, this is the radius, this is the tangent. This angle here is equals to 90 degrees. Reason being, radius is perpendicular to the tangent. Okay. Now we go for C, the cyclic quad. I don't think there's any cyclic. Oh, yes. This is the cyclic quad, RTAP. And each four vertices touches the circumference of the circle. Therefore, angle A and angle R2 are supplementary, and angle P2 plus P3 plus P4 and angle T1 and T2 are supplementary because opposite angles of a cyclic quad are supplementary. Then the tangent, the tan chord of X between the tangent and the chord. Therefore, we go to that angle here. On this triangle, we have X here. Then if it's X here, this will also be X because these angles are equal. Okay, now on the smaller circle, okay, we don't have any other angle that you can use tan chord on. Now, let us jump into the problems and see what we can do. Now, we are required to prove that PR, which is this one, bisects ORN, bisects this angle, which is to prove that R2 is equals to R1. Now, what are we going to do? We said we know that OPN is equals to 90 degrees. Why? Because the radius is perpendicular to the tangent, right? Yes. Now, what is P2? Angle P2 is, this is degrees. P2 is 90 degrees. What? P2, not just P. P2 here, this part. Remember, we said this is 90 degrees, OPN, right? Now, P2 will be 90 degrees, the whole of 90 degrees minus X, right? Now, R2 is equals to 90 degrees minus X is equals to that angle P2. Why? Because those are the angles opposite equal sides. Angles opposite equal sides. Sure. Now, let us find R1. How can we find R1? Now we can simply say 180 degrees minus 90 minus x. R1 is equals to 180 degrees minus 90 degrees minus x. This gives me 180 minus 90 gives me 90 degrees minus x. Now, we have proved that R1 is equal to R2. Therefore, we've proven that PR bisects ORN. Now you have your beautiful 5 marks inside the pocket. Let us go and have a look on the last one, which is now to prove that PAT is equals to ROS. Now, PAT is this one, right? Now, what are we going to do with this PAT? What is going to be our first thing to find that angle A there? So, okay, this is what we are going to do. This angle here, what is this angle here? This angle is 90 minus x, R2. So we said R2 plus angle A is equals to 180 degrees. Reason being, opposite angles of a cyclic quad are supplementary. What is R2? Is 90 degrees plus A, or 90 degrees minus X plus A is equals to 180 degrees. Therefore, that angle A, which is PAT, is equals to 180 degrees minus 90 degrees plus X. It gives me 90 degrees plus X. So here we are having 90 degrees plus X for this angle. Now, we need to find the angle ROS. ROS here. And what is that angle here? So we said this angle S1 is 90 degrees, right? So S1 is equals to 90 degrees. Why? Angle in a semicircle, right? What is this angle here? It is x because it is equals to that one. Now, angle P3 is equals to angle T1. They are both equals to x. Angles opposite equal sides. Opposite equal sides. Now we want this angle O2. O2 will be equals to 180 degrees minus this 90 minus x. It gives me 90 degrees minus x. Now let us come and look for this one. O2 will be equals to 180 degrees minus this 90 minus x. The bracket 90 degrees minus x, okay, and minus this 90 minus x again, minus this 90 minus x again. Now, what am I going to get for this one? Let's see. I'm going to have 180 degrees minus 90 degrees plus x minus 90 degrees plus x. This cancel out. Then I'm now left with 2x. So this is 2x. Let us add the 2 and see what we are getting and see if it will work. But now we are going to have, what is O2? We said O2 is 90 minus x. Okay, now angle O2 plus angle O1. What is O2? 90 degrees minus x. Now plus 2x. 90 degrees, 2 minus x is plus, how do you say, plus x. So now O1 plus O2 is this angle. It is 90 plus x. And A here, it is 90 plus x. Therefore, you can conclude that angle ROS is equals to PATY because they are both equals to 90 degrees plus x. Therefore, we are done with approaching these problems right. So now, before I can conclude with this lesson, I have to remind you guys about this DRCPT. The DRCPT says D is the diameter. You will look for the diameter that you are having here on the diagram and then applies every theorem that you know about the diameter. Angles in the same circle or angles obtained by the diameter, then you proceed. Every theorem that is talking about the the radius is perpendicular to the tangent. The radii are equal, maybe, and see if we are having an isosceles triangle so that you can have the basis of an isosceles triangle or angles opposite equal sides. Okay. And then the C cyclic quad, you know the properties of the cyclic quad, that opposite angles of a cyclic quad are supplementary. Exterior angle of a cyclic quad is equal to the interior angle opposite of a cyclic quad. Now, we also have angles in the same segment, angles subtended by the same diameter. Angles subtended by the same arc or same chord. Okay, P parallel lines. You know, if you are having parallel lines like this is your transverse line. This angle is equals to that angle. Now they form your Z. These are the alternating angles. And then when you state to alternate angles, please also state parallel lines that you are given, that maybe AB is parallel to CD, always. Now, angle this one and this one are supplementary because they add up to 180 degrees co-interior angle. Also with co-interior angles, state your parallel lines, okay? And we have corresponding angles. This angle is equal to that angle corresponding angles because AB is parallel to CD. Fine. Now let us go for the triangles and talk about triangles. We talk about isosceles triangle a lot and the exterior angle of a triangle. So always when you are having a triangle with two equal sides, these angles will always be equal, and your reason will be the base of an isosceles triangle or angles opposite equal sides, because this angle is opposite that side and this angle is opposite that side, right? Fine. And then you go to the next part, next kind of a triangle. If you are having a triangle of this form, this angle is equals to that one plus that one. Reason being, the exterior angle of a triangle is equal to the sum of interior opposite angles of a triangle. I hope that makes sense to you guys. Now we can end here for this lesson, guys. I hope I'll see you again in some lessons. How we'll be doing that topic. I hope you guys enjoyed these lessons.